Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. You can recall that in the last couple of lectures we have discussed about different types of simple operations in the R software. Now in this lecture we are going to talk about one more aspect, which is matrices. So you must have learnt about matrix theory. We are not going to use actually the matrix theory, but in many situations the R demands the data to be entered in the format of matrix. So that is why in this lecture my simple objective is to give you an idea that how are you going to create the matrix and how are you going to enter the data into a matrix framework in the R software. So I believe that you have some elementary idea about the matrix operation like addition, subtraction, multiplication, etc. So I will be using only those things. So let us try to begin the lecture and let us see how a matrix can be created and how the data can be entered in a matrix in different ways. So firstly, let us try to understand what is a matrix. So a matrix is a rectangular array in which there are certain number of rows and certain number of columns. So say there are p number of rows and n number of columns. And all the elements in the matrix, they have got an address which is denoted by their location on the ith and jth places, that is the ith row and jth column. So inside the book, usually we try to express such elements as say xij. Ij are written in the subscript, but when we are trying to indicate in a programming language, usually you will see in most of the software it is written like x inside the square bracket I comma j, where I goes from 1 to p and j goes from here 1 to n. So here we are going to consider only the numerical matrices in which all the elements are some real numbers only. So firstly, let us try to understand that how we are going to create a matrix. Suppose if I want to create matrix of order 4 by 2, right? 4 by 2 means there are going to be 4 rows and 2 columns, right? So in order to define a matrix, the command in our software is matrix, M-A-T-R-I-X, which are all written in the lowercase. Now if you try to see, when you want to create a matrices, what are the different parameters on which you have to give the information? The first thing we want to specify that how many rows are going to be there. So this is indicated by the parameter n row, N-R-O-W. So you want to create a matrix of 4 by 2 order. So the number of rows are here 4. And the second parameter is the number of column. So which is here n col. There are going to be 2 columns. So I will set this parameter n col as equal to 2. Now the matrix is of order 4 by 2. So there are going to be 8 values which have to be entered. So these values or the data which has to be entered inside this matrix is given by the parameter data. And suppose I am just taking here simply 8 values which are in the format of a data vector 1, 2, 3, 4, 5, 6, 7, 8. And if you try to see the outcome of this matrix is stored in X, which comes out to be here like this. So if you try to see what is happening, the data is here entered like this 1, then here in the second row 2, then in the third row 3, then in the fourth row 4. After this it goes to the second column, and in the first row it is entered as 5, then here 6, then 7, and then here 8. Right. So if you try to see, the data is entered here like this, first in the first column, then it goes to the second column, then it comes to the second column, and so on. Right. So this is what you have to keep in mind, right? Because this can be different ways also. So if you try to see, there are 3 parameters which I have explained you. N row defines the number of rows, N col defines the number of columns, and data assigns the specified values to be assigned to the matrix. Right. If you want to access any single element from this matrix, then the command here is like as a x inside the square brackets, you have to write I comma j. So I is indicating the row and j is indicating the column. So if you try to see, suppose I want to access the element at the third row and second column. So I will write down here the name of the matrix, which is here x, and then inside the square brackets I will write 3 comma 2. So if you try to see what is this value, third row here is like this, and the second column here is like this. So the value at the intersection here is 7, which is coming here. So this is how you can access any particular element of the matrix, right? And suppose if you want to create the matrix in a way such that instead of data which was entering here as in the format of a here column wise, if you want to do it row wise, that means data should go like this, then to the second row and this way, then the option here is you have to add by row is equal to true. So by row, if you make it false, that means the data has to be entered by row is not correct, so the data will be entered column wise. But if you make by row equal to true, that means the data has to be entered row wise. So if in the same command what I used here, this command, I am just adding here one option here, by row is equal to true. Now you will see what happened. Once I do it, then you see how the data is entering into the matrix X, which is stored here. The first value comes here, then the second value comes in the second column. Then it comes to the second row, value 3. Then the value 4, which is the next value, go to the second column. Then it comes to the third row, and the value here is entered here is 5. Then it comes to the second column, the value entered here is 6. Then it comes to the fourth row, and both the columns are entered with 7 and 8 respectively. So you can see here by using the option here by row is equal to true, you can enter the data column wise also, right? So this is another way of entering the data, right? So, and I just want to show you here that by adding here by row equal to true, we have got the column wise data. And if I try to use here by row equal to false in the same command, then you get the same data which we have entered 1, then 2, then 3, then 4, and then 5, then 6, then 7, and then 8. So by row equal to false is the default option. Even if you don't write, it will not make any difference. But if you want to enter the data in the column wise, then you have to write by row is equal to true. This is what I wanted to show you here, right? So if you, before going forward, let me try to show you that how can you enter this data. And suppose if I want to create this X matrix on my R console. So I just try to copy this data, and if I say here X, so you can see here the data is entered here like this. And if I want to know the value on the third row and fourth column, then it will come here out of bound. Why? Because if you try to see, there is no fourth column, right? What you have to do here, the maximum number of columns here are 2. So either you can press here 1 or here 2. So if I try to make it here x3 comma 2, then it will come out to be here this value 7. And if you try to add here in this command that by row is equal to here true, then you will see here now this x is like this. So if you try to compare here this value and here this value here, both are different. So this is how you can enter the data row wise and column wise in the R software when you want to enter the data in the format of a matrix. Right. Now if you try to see, we have different type of operations in matrix theory. There are number of operations, but my objective is not to give you the details of all the operations, but I simply want to illustrate that such operations can be done. One of the popular operation is transpose. So what is the transpose of a matrix? In the transpose of a matrix, the rows and columns are actually interchanged. For example, if I take this matrix here, so its transpose will be like the rows and columns are going to be changed. So the first column here is 1, 2, 3, 4. Now it becomes 1, 2, 3, 4 as the first row, and the second column 5, 6, 7, 8. This becomes as the second row 5, 6, 7, 8. So let me try to show you this operation on the R console, how you can get it done. So you see, I take here the same matrix of order 4 by 2, which is here like this. So if you try to interchange its row and column, what will happen? This first column will become 1, 2, 3, 4 as first row, and second column will become second row as 5, 6, 7, 8 like this, right? So in order to do it, command in the R software for obtaining the transpose of a matrix is TX. So T inside the parenthesis, you have to write the X. So as soon as you write here Tx, you can see here, you get here the same matrix which you have obtained here. 1, 2, 3, 4 are the first row, and 5, 6, 7, 8 is the second row, which used to be the first and second column in the matrix X. Right. Similarly, if you want to make here multiplication in a matrix, then we have two options. We can multiply a matrix by a constant, or we can multiply a matrix by a matrix. Well, you have to keep in mind that whenever we are trying to do addition, subtraction, multiplication in matrix, then there are certain rules which are followed. I'm not discussing here those rules, but I believe that you are well aware of them. And under only those rules, we are going to make these operations, right? So suppose if I try to consider here a matrix like this one, which we have considered earlier also, right? Say X containing of data 1 to 8. And if I try to multiply this matrix by a scalar, say 5. So whenever we are trying to multiply a matrix by a scalar, then the scalar multiply each of the element in the matrix. So if you try to see here, if I want to multiply by 5, then this is my here matrix. 5 is multiplied at each places, right? And this is here the outcome, right? You can see here, right? So matrix multiplication by a scalar is simple and straightforward, and the operator here is only the star, which is the usual multiplication sign, right? And now I want to show you here one thing more, that if you want to multiply two matrices, so we know that if A and B are two matrices, then the multiplication is possible is only when suppose A is order m by n and B is order of n by p. So the multiplication is possible only when the number of columns in A and the number of rows in B, they are matching, right? So when we are trying to take here this here matrix here X, so you can see here this X matrix is of order 4 by 2. And when you are trying to take here this matrix here trace of X, then trace of X is of order 2 by 4. So if I try to consider these two matrices, trace of X and this X, then the first thing what you have to keep in mind is that the matrix multiplication operator is like this, percentage star percentage, right? So this will facilitate the matrix multiplication of these two types of matrices. And right, so if you try to multiply here, say the trace of X into X, both are matrices, then you will get here cases of order 2 by 4 and X's of order 4 by 2. So this is matching. So the resultant matrix will be of order 2 by 2, which is here like this, right? And similarly, if I try to create here two matrices, then I can give you the idea of addition and subtractions also. So suppose if I create here two matrices of order 2 by 2. So for example, here if I try to take here the data 1, 2, 3, 4 in one matrices and the data 11, 12, 13, 14 in another matrix. So you can see here this I have created two matrices here Y and Z. Right. Now if I want to first multiply Y and Z together, you will see here the operator will be Y percentage star percentage, and this here, these are the values of the product. Right. And now I want to show you here the addition and subtraction. So in this case, I'm trying to create here two matrices of the same order. So let me try to take an example of X where I have taken 4 rows and 2 columns and the data is from 1 to 8. So this is my here matrix here X of order 4 by 2. And similarly, I try to take one more matrix just by multiplying 5 into X. So this will also be of order 4 by 2. Right. Now if I try to add X and this 5 into X, then what happens? This addition as well as subtraction, both are happening with respect to the element wise. That means the element at the first row and first column of the first matrix is added to the element on the first row and first column of the second matrix. Or in general, if I say element at the ith row and jth column in the first matrix is added to the element at the ith row and jth column of the second matrix. And the same thing happened to the subtraction also. So you can see here, if you try to add here x and 5 star x, then the outcome will come out to be here like this. And if you want to subtract x minus 5 into x, then the element wise subtraction will also happen and you will get this these values, right? So, and similarly, if you want to take here one more example, so you can see here, as I said, we have created here two matrices y and z, both are of containing the elements 1, 2, 3, 4 and 11, 12, 13, 14. So if you want to add it, that means 1 and 11 will be added, 2 and 12 will be added, and so on. And if you want to subtract it, the same thing will happen with the subtraction. So you can see here that y and z, they are added here, and y minus z is here like this. So these are pretty smaller things which I want to show you. But before I try to show you these operation on the R console, let me try to show you that you can also extract the information on any rows or any column also from these matrices, and how to get it done, right? Suppose if I take here a matrix like this one, 4 by 2 matrix, where the data is like enter, and now suppose I want to have the information on the third row, that what are the elements on the third row. So how to get it done? You just write down the name of the matrix X, and after that you see this is your here third row. So you simply have to just write this information over here, that square bracket 3 comma, after that there is nothing, this is blank. So this will give you the information on say 5 and 6. And similarly, if you want to know the information on the second column, so second column will be here. So you can see here you have to give this information and say X, and then inside the bracket you have to write the same thing here like as here, that blank space comma 2. So this will give you the information of the second column, which is here 2, 4, 6, 8, right? So now let me try to show you these things on the R console, but before that I can also show you that how you can extract the information on submatrices. Submatrices mean you want to extract the information on certain number of rows and certain number of columns from this matrix. So suppose for example, I try to take the row number 1, 2 and 3, which is indicated by 1 colon 3, and column numbers 1 and 2. So, and I have the same matrix here, X here like this. So if you try to see, when I am trying to extract the information here, this comes out to be like this. Row number 1, 2, 3, these are here like this. And then I am trying to say column 1 and 2. Column 1 and 2, they are here like this. So if you try to see, this is the part which is common intersection. So if I try to do it here, you can see here this data is coming here 135, which is here 135, and 246, which is here 246, and this is here the outcome. So let me try to first show you all these operations on the R console also, so that you become more confident about them. So I already had taken here this matrix here X, but let me try to create it here once again so that there is no confusion. So let me try to take here X matrix here like this. You can see here this is your here X. Now if you want to find out here this trace of X, so you can see here. This is here like this trace of X. And if you want to multiply this matrix by here 5, so you can see here 5 into X is here like this. Alright. And if you want to multiply here trace of X and here X, so that means percentage star percentage X. So you can see here this will be a matrix of order 2 by 2. And on the other hand, if you try to take X into trace of X, so what you will see, this order will be now 4 by 4, right? So this you can see here, this is not a very difficult thing. And similarly, if you try to see here, I have shown you. And suppose if I try to create here two matrices here Y and here Z, so you can see here, this is here my Y and this is my here Z. So you can see here this Y here is here like this and Z is here like this, right? So now if you want to multiply here both the matrices here Y star, suppose if I want to multiply only by here 6, then it will be multiplied by this. But if I want to multiply Y into Z, then you have to, and if you want the matrix multiplication, then you have to percentage star percentage z. So you can see here, this is here like this, right. And similarly, if you want to add here y plus z, so you can see here y plus z here is like this, and say y minus z will be here like this. So you can see here how this is happening, y plus z, 1 plus here 11, which is here 12. And the second place it is 2, and then here 12, 2 plus 12 is 14. And the same thing happens in the case of subtraction also. And similarly, if you want to see here one more example, so x here is like this, and 5 star x here is like this. So if you want to add here 5 star x plus here x, so you can see here then element wise addition, and if you want to make it here 5 star x minus x, so here this is a sort of this subtraction, right. Now similarly, if you want to see here, suppose if you want to extract the information from this x matrix on say second row, so you have to type here x bracket 2 comma, and then you have to make the bracket close, so you get the information on the 2 and 6. And similarly, if you want to confirmation on the second column, so you can see here the column here is given by bracket comma 2. So you can see here 5, 6, 7, 8. So this is how you can get a conformation. And if you want to extract a submatrix, so I can see here 1 to say here 2 means row number 1 and 2, and column number 1 and 2. Right. So you can see here you will get here this submatrix over here. So right now means I have given you basic idea about this matrix operation. Well, as I said, there's a whole matrix theory which is on which statistics is actually based, and my objective is not to teach you here the matrix theory, but I wanted to make you only confident that matrix theory can be handled in the R software using the rules of matrix theory. So I have, and in many places you will see that when we want to enter the data for any statistical function, then the requirement is to enter the data in the format of a matrix. So these commands are going to help you that how can you enter the data in the form of matrix. But well, I will stop here, but your job starts from here. I have taken very simple operation, but there are many other operations which you might be using in your respective areas, right? And they will be related to matrix theory. So my request to you will be, why don't you try to do the same operation in the R software? And moreover, it is more important that if you have got a data set, then, and if you want the data set to be stored in a particular structure, then how you have to manipulate with the parameter like n row, n call data, so that you get the data exactly in the same way which you wanted, because this data is going to be supplied to some function. For example, you will see there are certain types of bar diagrams where you need to give the data in the format of matrices, and it depends that what information you want to retrieve. Based on that, you will have to create a matrix. So it is important for you to learn that for a given set of data, what type of commands you have to give so that you get the required outcome. So with this point of view, you try to take some example, try to practice, and I will see you in the next lecture. Till then, goodbye.